Hello. All right. Apologies for starting slightly late here. Hopefully everything is working. I was just wrapping up a couple of calls and that went over a bit, well, half an hour longer than expected. So I'm not quite as ready as I normally am for one of those live streams, but trying to get there real quickly here. And let's see, so I'm just gonna need a terminal later on, so let's get one of those going. Just making sure it's got the right size, we're good. And here we go. Also, yeah, sorry for the different time slot than usual. Same reason, just meetings, and had to kind of work around that. Alrighty. So let's start with the usual update of where we're at. Can do a quick demo of things hopefully working. I'm saying hopefully because I've not actually. One of the things I did today was push a new update, and I've not had time to test it. So you're gonna get to do that with me. But let's just take a quick look as to where we're at since last week. So, we've done a bunch of work on Operations Center, and that showed a few kind of gaps in small issues with IncusOS. So we've been plugging those, basically getting the hardware address kind of propagated through. The roles is what we handled in the last live stream. Few more tweaks here and there that kind of happened. And then the main change I did was yesterday was switching to the production keys. So that's what I'm saying, we're still kind of doing testing and hoping that everything works because it's still pretty early on as far as running systems with the new production keys. In theory, all of the right pieces have been put in place, but you know, some stuff might be missing. So anyway, let's try and get it going. So I'm gonna need the new ISO, and now everything is uploaded onto the new site, which is wrong. Okay, well, we're gonna start by fixing that. Okay, it's still a very manual process right now, which is part of the issue. So if I go on the master server, I can see here that stuff is in the publish folder when it should actually be in the parents. So just fix that. That view is not correct, but for it to publish, I need to actually have the publishing script run at least once. And I don't know if, funny enough, the publishing script is the Jenkins import logic, so I need to actually have it do an import from Jenkins. Hopefully there's nothing to publish right now. We see a whole bunch of stuff are being skipped. That's because they've not completed the build or are not fully tested. So hopefully, there we go. Got to the end, so that means that did a publication event. So if we refresh here, we're good. Okay, so now I can grab the, which one do I do? The ISO, I think, is what I usually use now. So let's grab the ISO. Here we go. And then we're gonna get to play with that. So I'm just gonna get disconnect from that server, go in the demo folder over here, just getting YouTube visible here. There we go. Need to replace that ISO image with the new one I just grabbed, which is, who knows, 00550, this one. And then need to decompress it and change the script, and we get to actually test that one. There was a small issue with the first connection to the image server to download the applications. So that's why there's effectively been that rebuild. And I'm hoping that ISO fixes that issue because when in a VM, I can work around it. But when run on physical hardware, it's a lot harder to work around that little issue with the new download server handler. So just changing that name and then running the demo script, which basically just creates a VM with basic seed data. So if I start demo OS console, we should see it do the enrollment. Here we go, and come on, key enrollment is done. And now we just need to attach to the main console and see what it does for install and then for the boot after that. There's quite a few things cannot play to get us onto the new production signing keys for this, and having like a clean migration path for existing systems. So hopefully we got everything right. All right, so this is done. It's installed. Now we can just incus stop demo OS, remove the install media, and then start it back up with the console. And we'll get to know whether my fix worked. Okay, so just starting up here, and because OSD should kick in. Come on. Okay, there we go. So IncusOS is running, key generation, that part worked. It's afterwards when network was being brought up, there was a small race condition. So I'm kind of hoping the retry logic works now. Bring up network. Yes, it worked. Sweet. So now it's done loading the application. It's going to do the initialization. Will be all good. Bring up local storage, starting application, initializing, system ready. System ready. There we go. Okay, so that's up and running. If we go poke at it, we can look at some of the new cool stuff in there, which again is mostly switching to the new keys, but we do have an API that let us check that now. So we can do system. It used to be system encryption and system security. We moved it. And if we look at that, we can see the two encrypted volumes. They're currently unlocked. They're tied to a TPM, so that's all good. And we also export what's found in the secure boot PKI. So that's where we can see the new signing keys now. We didn't clean enrollments. We've got even a platform key that's loaded. We can see it's issued by the main secure boot signing key that we have. So secure boot E1 is signing this key. Then in the key enrollment key keyring, well, that's a mouthful. We've got the KEK R1 key that's loaded in there. And then finally, for the actual image signing, so that's the DB keyring, we've got secure boot 2025 R1 loaded. That's what signs the current image. And yeah, we're basically in good shape. TPM status is okay. Secure boot's enabled, so everything is good. And yeah, we're correctly initialized, got the host name. Yeah, all good. So, and obviously we've got Incus running, we've got, storage, network, all that stuff is up and running. So that's completely functional. That's basically the state of things. We didn't do a ton of work over the past week, but it was mostly because we're dealing with first switching to publishing to the new image server without changing the keys. And then over the past 2 days, I handled actually switching to the production keys, which is what we have now. Fixing a few issues here and there, tweaking the building logic on GitHub and getting us up and running. So that's all good. Now, what is this live stream about? Well, because I kept the name and the title and stuff a bit unclear, I think. Oops, I'll just close this thing. There we go. Okay, just another web browser getting in the way here. There we go. So right now, if you want to install this yourself, you kind of have two main options. One option is you use the Flasher tool, which is not the easiest thing to get to. I don't even remember if we expose it on the image server. Sorry, it's gonna be quite bright again. If we look at one of our images, do we have the Flasher in there? We do not. So you don't even get the flasher that way. You need to grab the latest release. And another heads up on that, those releases, we've stopped publishing new ones. And we will stop publishing new ones for probably a week or two, possibly after I get back from travel. Because if we publish anything new now, we're gonna break updates for anyone who's been using the very old, well, an older version of IncusOS and hasn't updated in the past few days. So we're gonna just give a bit more of a grace period for that, effectively giving another week or two for people to get to update all the way to this version on the older logic, effectively. And then once they're all on this version, they will be using the new image server and will get the new the new images that way. Then once we get back, we'll probably delete all of those releases that are using the old signing infrastructure, and then change the logic again so that we do start making releases automatically again. But they won't have all the files. They're just gonna have the ISO, the disk image, the ISO, and the flasher tool. And all of the other files will only be available through the image server. So that's roughly the idea for this stuff. Now, as I said, you've got kind of two methods to do it. You could go and download the flasher from here, and then the flasher would download the latest version from GitHub, which is this guy. Put that on your system. It will then automatically update on the next boot to pull from the new image server and then reboot again, and then it will be fine. The other way you can do it is what I did for the demo just earlier, and you do it by hand. So if I go in that demo folder and look at the script, demo.sh, I took the ISO, uncompressed it. The script copies it as install.iso. It generates a seed from some YAML files and writes the seed at the right spot in the image and then starts it. Honestly, the flasher tool is easier to use, but it's still kind of rough because you need to get the flasher tool on your operating system. You need to run it, you need to go through that. What we'd like to do is actually something much simpler, which is, go on the Linux containers website. Under Incus, there should be like an IncusOS page, and you go in that page and you can just say, effectively answer a form of what do you want? Do you want to install from an ISO? Do you want to install from a USB stick? And then potentially pick the version you want. In practice, we'll just use latest for now. And then at least provide the certificate that should be trusted. So effectively the result of Incus remote get certificate, I think it is. Apparently not. Get client certificate. Okay, so effectively having a way to dump that and then download an ISO, well, also answering how you want to install it, actually just like automatically find a drive, install it, wipe it, go. Or do you want to install on a specific disk? And like, should it just wipe the disk or only install if it's empty, that kind of thing. So just a few tick boxes effectively that will effectively generate the seed files. So the install YAML and the Incus YAML especially. And then you download the file and it already has the right seeds in place, and you can just, write that, either boot that ISO in a VM or something, or through the BMC of a server, or you can write it to a USB stick and boot an actual system from it. So that's kind of the idea. And doing that should be pretty straightforward, actually. We just need somewhere with the two image files, and let me just clean up what the mess I've got in here. Don't need that, don't need that. Okay, so I'm just gonna create a folder called images, and then in there I want two different files. So basically for that latest image, I'm gonna download both the ISO and the disk image. So effectively I'm gonna have a server that's got those two files on disk. All right, here we go. Now I need to just move them into place. So I've got those two in place now. And what I want to build now is just a tiny piece of code that should start a HTTP listener with a REST API on it, and effectively just one endpoint on the REST API to be able to download to post some data, which would be JSON input, and in response get an ISO. And that should be pretty easy then, because we can very easily write a bit of JavaScript on a website and have it do exactly that, where we fill in the form, we have the, when you hit I want this thing, we just post that, and the response is a pre-generated ISO for you. And because of the way those files work, we should be able to have them compressed on disk, read them through a decompressor, transfer the data up until we get to the point of the seed partition, then read from the state that we generate from within the code for that amount of data, and then continue reading from that point on from the original file. Effectively letting us generate those kind of customized ISO completely on the fly. We don't need to write them down to disk. We don't need to use a lot of memory. We can just do it completely on the fly. So that's the idea. That's what I want to start experimenting with in this live stream, and just see how far, like how easy it is to get to do that. So we already have a few tools effectively inside of the IncusOS code base. We've got the Flasher tool, we've got the image publisher, which is the tool I kind of use to create that web tree that we've got here. Well, just the parent actually, this kind of web tree with the index JSON that has the details for all the files and all that. So that's that tool. Now it would make sense to have another tool, which is actually what we run on the on our server infrastructure to serve the customized images. So I don't know if we can call it, we've got image publisher, let's call it image customizer. So let's do that. And in image publisher, confused. Why is it treating that as not a folder? I'm so confused. Oh, okay, because I'm in the wrong place. That's why. Never mind. Image customizer needs to go into CMD. There we go. Need to add it to git ignore. So let's do that. Just a bit of boilerplate here. Okay. And then so image publisher, that's just main.go. Okay, fine. Can just get the rough structure from it then. Okay, package main is used for the image customizer, just making things happy. Okay, main has just like a small wrapper to do error handling for us, and then the do function actually does the rest. We just need an image path as the first argument. And then I think what we'll do is just symlink. So I'll effectively do a symlink from this guy to image.img.gz, and then another one for the ISO, image.iso.gz, just so we can guess, well, so we know what files we can just read, don't have to think about versions very much. So that will be good. We don't really need to have any of that other stuff, because that's from the other code base, so I can just get rid of it all. There we go. Return now. Yeah, we don't really want to open any of those files right then. We can just make sure they exist. Image files exist, so we can just get that, and then just do a basic stat. So just start on file path join of image path, and we want image ISO GZ. So just wrapping that error here. So that's for the ISO, and then for the image, it's a D. ISO. Okay, so that's the most basic. What do I actually use in there? Use errors, format OS, context possibly. Definitely don't use that. Errors, format, OS. That might be it. So just see if that builds. Yep. Image publisher, missing target path, fine. Oops, that's the publisher. Image customizer. I'm too used to dealing with the other one. So actually build the wrong thing to customizer. Ah, yeah. Missing file path and variable route line 43. Okay. Yeah, makes sense. And I was kind of surprised that I managed to make it build the first time around. That would have been surprising. Okay, now it works. So image customizer this time. Okay, so that's all cleared, all the files exist, yay. Next step is we need to actually start a small REST API. Start REST. Jared says like you've done it before as far as like actually writing a full file and building it the first time around. Yeah, it happened before on stream. Yeah, that's true. I still consider that to be a miracle. It basically never happens. There's always a missing import, always some variable definition that's wrong somewhere. There's always something. All right, let's see. So I just kind of need to get some of the boilerplates that we had, that we've made for IncusOS. It's gonna be just saving me some amount of time. Okay, so there's rest.new server, and that means we've moved that logic into. I don't think it can straight up reuse the package. I don't think it's really meant for that. Yeah, it doesn't look like it is, but I can at least take the logic easily from there. Okay, server, there we go. So that's kind of the setup listener thing I need. So dot copy paste, and we'll just do API route. Yeah, we're gonna use some amount of boilerplate stuff, I guess. Okay. So stash. We don't need the debug one. It's gonna be customize. And that goes into API customize. This was using an actual shared struct, which I'm not using right here, but I don't know if it's useful yet. So let's see. What did we do on the shared struct? Not a whole lot. This one was using it because it accessed the state and some other stuff. We don't really need to do any of that here, really. So I don't think I need to go through a shared struct. I can just do something like that. So that's the function for API root. So we'll probably want. Okay, so that's API root one. Oh yeah, I don't care about this one. What I care about is this guy. Some equivalent of it anyways. And so we're just gonna check the method and return the /1.0 endpoint. So that's the API root function. For 1.0, I think we just return nothing basically. Just return an empty response because there's no real version or state or anything that we really want to return. So I'm just gonna do this here. It'll probably just do an empty map string, any nothing. So that way it's initialized, but we don't really return any data. Okay, so something along those lines that should give us the, well, need to clean up that one. Those two endpoints, and then for the thing we actually care about, it's the customize endpoint. So that's the one we need to actually implement. API customize. So for now, it returns nothing. The only method that we want to support is post. So everything else should fail. It's fine. Here we can see we have the listener being created on some socket. That's not actually what I'm gonna want here. I'm gonna want TCP and something along those lines. I mean, 8080 is more traditional. I think it's available on my machine, so I can do that. We need to actually hook up that listener. Okay, so once everything is done and the actual server setup, and then returns the serve function. Okay, so we need to do that here. Okay. And we get an HTTP server, router, timeout, return the thing. Okay, that should be fine. It's gonna fail to build, obviously. Net, HTTP, time, response. Okay. Let's do that. Net, HTTP, time. Response is one of our internal packages, so I'm not sure the exact path for this guy right now. Let's go look it up. It's this. No, that's state. Where is response? It's under rest. Okay, so rest response. That was easy and unexpected. Okay. Run that. It's listening, so that's cool. Now let's try the API. 8080. Cool. That's actually made me do the rendering, but it shows 1.0. 1.0 is a success. If I go through, I'm getting the 404, and if I do customize, not implemented, if I post to it, it responds. Yeah, okay. So that's excellent. Now let's try to just make it actually download something. So API customize, we're doing like a sync response thing. That's not gonna work. We've got other response types that are meant for file transfers. So let's see if we can use one of those. I don't know that one of the file responses are gonna work, but we might need to, there's another one that's manual that's kind of designed for most flexibility, which we're probably gonna want to use. Let me see. Okay, manual response is here. I don't think I've got, maybe we didn't implement the file one in the shared code base. Oh no, file response is here. But file response effectively reads, like it expects the size, which we know, and it expects a read seeker, which we can't really provide because we need to be able to inject stuff as we're reading. It's kind of interesting. We might be able to make it work actually with this, but I think manual will be easier. Let's see, is there an example of using manual response in this guy? No, there's not. There should be one in the actual Incus code base. I'm sure you've used it a few times there. Indeed we have, including for the IncusOS proxy itself. So that one I know I wrote not too long ago, so I can go look at that. And manual response effectively gives us straight up access to the response writer, which is exactly what we want. So we can write data directly to it. Basically, we need to make sure not to write any headers or any of that kind of stuff, because otherwise it's going to screw up the download. So that should be fine. So let's do that. So instead of sync response here, we want manual response. And then the manual response gives us access to the writer. So response writer error and something along those lines. That stuff can return an error, but I don't think those functions do error handling. Yeah, not really. Okay, so that's fine. Response writer func this guy. Why isn't it? All right, there's a missing opening here. Okay, that makes more sense. And then return nil, assuming everything works. So that's where we are technically able to directly write into it. W8. Oh, it's actually no, never mind. We do have access to the full response writer already, so I'm not sure why I'm doing this. We don't actually need that. That was a lot of work for nothing. I mean, not a lot, but that was work for nothing. Okay, so if we are sending an error, then we should set application JSON. That makes sense. Now, if we're not, we should behave the same way we would if we were to actually download the image. So if I go here and I get the ISO, we can see what I'm getting out of Nginx here. So a bunch of TLS stuff, don't care about any of that in this case. This is the request. We can see get, user agent, whatnot. Doesn't matter. What actually matters to us is the response, which is what we have here. Don't care about the date. The content type we do care, so we need to set that one. Okay, and for things to work properly, we should also set the content length, which we are definitely able to get. Well, we don't yet know what the user requested, but let's do image size. Say we want to read closer for the image itself. So let's do OS open file path join. First argument passed to the script, and then it was image.isogz. So let's do that. Oh, that's actually kind of interesting. Because the ISO is compressed. Because it's compressed, we might not know its size. Let me check. Because I don't know, like, the idea is to be able to return it to the user pretty easily. I mean, the user technically doesn't need to know the length, but it would be nice if we could. Because the idea I've got is effectively, if we can do transport compression, so there's effectively the deflate support in HTTP, then we could return it compressed, have it be decompressed by the web browser. So the web browser downloads, looks like it's downloading a .iso, it's compressed in transport, so we end up transferring 300 megs and not 3 gigs, which would be very good. But then if the web browser doesn't support it, what we would do is fall back to returning them an actual compressed stream as a iso.gz. Now the question is, can we, like for web browser progress, download progress, it would be nice to know the size. The size would be the uncompressed size typically in this scenario anyways. Now the question is the go like go zlib effectively, go zlib. Can you tell me the size? It can give me a writer or a reader. If it gets me a reader, it is just a normal reader. It's not a seeker. So it can't tell me the size. Yeah, it's unfortunate. Okay, well, let's make our lives easier then, and we're just gonna have the images on disk on the server itself just be uncompressed and save ourselves that having to deal with that effectively. So just decompress these two. At which point I can easily get the size from stat. So we're gonna do it that way, I think. Like, it's not like we've got any issue with disk space on the image server anyways, so that's not a problem. But it would have been neat to be able to use the exact same files, because then I could just do a symlink to the compressed file on the image server and just read straight from that. But yeah, if I do that, then I lose the ability to easily get the size out. So fine, we'll just... Oh, the difference in size is massive. And the difference in size is huge because this image needs to be pre-partitioned with the right sizes for EFI and for everything as we see it evolve in the future. So there's like a 2 gigs EFI partition and 1 gig system partition, despite us currently shipping 50 megs in the EFI and 200 megs in the system partition. So you end up with 3.2 gigs when the used space is in the 300 something range, or if you compress it very lazily, 475 right now. So the difference is absolutely huge. That's why we absolutely do not want to serve the uncompressed file from this thing. Over the wire, it needs to be compressed. Ideally, we do it compressed as part of the transport, so the user doesn't need to decompress by hand afterwards. But if that doesn't work, we will give them a .gz and then they have to deal with the compression on their side. Because otherwise we're going to be spending a lot of time transferring zeros over the internet, which is really silly, and we don't want to do that. So that's image img, and then this one is image ISO. Okay, so back in here, we can remove all the GZ stuff now. Okay, and then down there, now let's say we want to serve the ISO. I should be able to do that pretty easily. It's just kind of annoying because all of the error handling is less than ideal, let's put it that way, when you're within that function. It's kind of tempting to just do a wrapper and so on, but anyways. I'll just do it the copy-pasty way and can figure out a cleaner way to do it later. So set content JSON, response, internal error, and then the error string here, like that. Okay, so open the image file. Now that it's open, we need to just defer a closer for that. rc.close. Should be fine. And then we can do serve the image, so we'll just do that. And the way to do this, so we've got content type, content length. Is there anything else I need to set? Not really, the rest doesn't really it's not really needed as far as I know. So we should do that, and then RC, let me check. So OS open gives us a file, not just a reader. And from a file, I think we can just call size on that. Just checking the docs, but no, we need to call start on it, and then we can get size. Okay. The other way to do it is to seek to the end, which then gives us the size as well. It's kind of tempting to do that. Yeah, let's try it that way. Gets the size. So what we would do is rc seek offset 0 to the end. I think there's like a constant in the IO package or something we should use for that. But anyways, so that's gonna be the size. Silly error handling here too. And then once we've done that, we need to remember to, you need to rewind your tapes. So set it, rewind it back to the beginning, basically. There we go. Seek back to 0. And solve the image. So we just need to actually do the copy. I know we like copying in chunks to avoid loading everything in memory. So that's what we have kind of sprinkled everywhere at this point in the code base. I don't know if this, like, you'd think there would be a function that does that cleanly instead of having to do this kind of silly loops, but oh well. Not that we've found so far anyways. Let's do that. So let's copy in chunks of 4 megabytes. I don't need the size calculation stuff, so I don't need n. I don't need any of that. Okay, and there's more error handling we need to do here. Okay, and if we get that far down, we should be okay. There's an HTTP 200 code. How do we set that again? Because I don't remember what was the order. Yeah, it was the first thing, then followed by the headers. So we need to do that. So there's a right header call we need to do. I think response writer, right header. Does that take the sales code? I guess it does, probably. That's probably how we do that. Yeah, okay. So before we actually return the data, we need to do right header HTTP status, okay, and then we can start streaming the data. After that, we just close the connection and hopefully everything works. Okay, so it's complaining about a bunch of things. What's it saying about the size here? Declared not used size. Okay, well, we need to fix that. Okay, it's called image size later on, so it's just that image size, except we're gonna want that as a string. I2A image size. Okay. No, okay, so I need to import IO, strconv, so both of those. So let's import that. And here is the strconv, import that. Build. Now, couldn't use image size in 64 as an int. Fun. Okay, I was trying to be nice and use the nice and efficient way, but if I'm gonna have to convert it a bunch of times, I might as well just go the lazy way and use format to do that. Okay, then 1 for 1. Oops. Yeah, so I didn't actually change the loop. I should probably do that. We copy into something from something. So we copy into the writer and from the read closer, so from RC. Yay. Okay, so that built. Now, let's see. We've got the files on disk here. And the goal is to get effectively this file back, and it should be identical. So let's see. Curl 127.0.0.1, 8080, ISO, what was it, 1.0, customize of it. Outset ISO. Well, it would work better if I actually run the thing, wouldn't it? Yeah, run the image customizer. And that gave us a 501 not implemented because it's the wrong method, right? We need to do a post. And that's done loading stuff. Okay. Transferred, size seems fine. Octet stream, give us a file. Okay. The file is the exact same size, so that's a good start. ISO and compare it to outset ISO. Okay. Yep, we're good. So basic serving of that thing worked fine. Now what we need to do is to try and have it inject extra stuff in there, because that's where it gets interesting. So we've got that magic offset effectively. So if I go in demo and look at the script, we can see here we've got that magic offset. So basically we need to go at it by chunk, copy all the way to that particular chunk, which is, so that's a block size of 512. So that's the position in blocks. So if we want the actual position in bytes, which is what we need here, we're gonna need to multiply that by 512, which should be a bit after 2 gigabytes. Is that right? Yeah, okay. So we need to go all the way to that chunk. Then once we're there, we need to write some custom data, as in a seed file. And then whatever number of bytes were written from this thing, we need to go and then write the rest. So it's going to be a few loops effectively to get to that point. So write leading part, and we basically need to artificially limit it as far as how many bytes it's copying. So we need to basically set up a remainder. That's how many as it's supposed to be copying. Every time it copies, we can get the number of bytes copied, which we can then deduct from the remainder. And the chunk by default would be 4 megs, but if the remainder is less than the chunk size, then we need to shrink the chunk to the remainder. That's the idea. And hopefully that's how we're going to be copying the leading chunk of data effectively, at which point we can write whatever else we want, and then we need to skip that chunk from the reader and then copy the rest. And that should work. So let's see. Write speed file. So for that, I'm just gonna cheat and we'll just write directly from in here. So we'll literally go and read. Is there a seed data? No, not right now. So I can go in here. We don't need the network stuff. Let's just create a seed data, all the YAMLs, and just put the owner as root, the group as root. Okay. So that does give us a file of 10K that we need to now write at the right spot. We need to also open that. And we'll need to get its size as well. Actually, no, the size we don't need. We just need to open it. Okay. Open the seed file. So we do seed rc. Seed rc, and then hardcode the path for that. Okay. Now that I've got that open, what I can do is write seed file. So we'll just do another loop, which is way overkill because the seed file should never be 4 megs large, but Go static analysis is gonna get mad at me if we don't do a loop over it. So anyway, we'll keep doing a loop then. And we're just gonna copy, so not from, we're not copying this time from RC, we're copying from seed RC. Seed size, I don't know if it's in 64 or what, but let's assume it is. So we're just getting how many bytes of the seed were transferred effectively. And then we need to write training part. So what we need to do at this point is we need to actually seek. So the seeking logic we had here, we need that. So we need to just seek by the size of the seed file. I'm just checking for seed. I think 1 means relative to current. Yes. Okay. So 1, and then we need to move by the number of bytes of the seed. And then once that's done, we can go and actually transfer the trading part, which is basically the same loop as here, except we don't care about sizes or anything at that point anymore. We just go through whatever's left. So that loop again, and we're gonna read from RC in chunks of 4 megs, and disregards the size, we don't need it, and something else. Okay, 159 and not defined. Sure, fine, let's fix that. Okay, chunk variable int once in 64. Okay, so chunk here should have been clearly defined as int 64. Okay, then same thing here. Okay, now that builds. So let's see, image customizer. Now if I go in my images again and curl the image, we're looking for something that's the exact same size. So the size should be identical, but then it's not gonna be the same checksum this time around. Okay, something wrong happened here. We received all the way, so the leading part has been transferred, and then we're just stuck. So we're seeing 2049 has been transferred, and then that's it. And we're waiting, so that's not good. What happened here? Chunk. Oh, yeah, okay. I think we're just in an infinite loop. So that's basically what's going on is we're in that for loop. Normally we break out of the for loop when we hit EOF, which we're not. Instead, we keep going with like a reminder of 0, and we keep just trying to transfer 0 bytes and not going anywhere. So that's a bit of an issue. We just need to do like if chunk is 0, we need to break out of there. That should fix that. Let's try this again. So wipe the file, transfer it. Are we gonna get past the 20 something? Yes, done. Size is identical, so we're good. And the checksum better not be identical, since we do have data this time in that partition. But what we should be able to do is through DD reproduce the exact same file to just make sure that they didn't mess anything up. So I should be able to DD if, actually, copy this guy. Let's say test.iso. And then DD if the demo seed, so the exact same file it's used. Output file is test ISO, and then I never remember the actual offsets and stuff, so let's just go and get them again. Okay, so we want seek, block size, conf no trunk. Okay, so that's injecting the seed in theory the same way we just did with the tool. So again, they should all be the same size, but now the original image, the one that was customized that we downloaded, and the one that just got built, and hopefully we've got the same thing. Okay, DA3. Nope. Okay, well, that's unfortunate. What is wrong? Let's see if I can spot anything obviously wrong in there. So we went by chunk, then the seed. Okay. We got the size that was transferred. We move by that many bytes. Like it's probably an off by one thing somewhere. That's the idea. And then transfer the rest. Okay, let's see if it's completely busted or just slightly busted. So out.iso, oops. Come on, why can't I type today? That's pretty busted actually. Okay, or maybe not. I seem to remember it being more forgiving than not. Like an ISO is a weird format. It's not aligned on 512 bytes, aligned on 2048. It's normal that I can't straight up read it. Normally, it should have been complaining, but it's complaining more than I expected, honestly. Actually makes me want to redo the test, but not with the ISO, with the IMG, because it's going to be a lot easier to debug. So let's just do that. So basically, here we're going to customize it IMG instead of the ISO. So let's just do that. Build, run it, curl the thing as IMG. Because the IMG file is aligned on 512. So we can actually run gdisk and stuff on it just fine. Okay, so that looks correct. So the partition table itself is not messed up. So that's good. Now, do I have xdiff or something in here? I don't. Again, but I'm guessing it's an off by one thing. We just need to add some debugging in there. So let's see. Image size, we know this is correct. The read closer is here. Remainder is that. It's going to be in chunks of 4 meg, so if I dump debugging on that, it's going to be slightly unfortunate. It's going to be quite annoying to read. I would like to see the seed size. I'd like to know the new offset. That should help us figure out what's going on. Okay. By building node. Seed size 195. Yeah, it's written wrong. Okay. Let's run that again and call disk thing. Okay. That's a problem. Seed size 0. Okay. So that's explaining the problem. Now, why? Oh, yeah, okay. That's rather obvious. The seed size is less than the full size here. So even though we're hitting an error, which is an EOF, we should actually capture that. So that's the issue. Now, for good measure, we should probably do it here too, but the remainder is never used. In here, maybe? Nah. It really doesn't make sense in that one because we're not going to hit the UF. And if we do, then the remainder is never used. So it doesn't matter. So I think it was just the seed size we need fixing, but let's do it again and see what that looks like now. Okay, that's better. 10K, that's what we wanted to see. Cool. Again, we can do a test. So test.img, just gonna need. Yay, that's what we want to see. Okay, so that's the rest of the logic was perfectly good, it was just the size being wrong. Basically what I just did here is I manually created a seed using DD, compared it to what I downloaded from the customizer, and we're getting the exact same checksum, so we're good. Yay. So in general, that shows the logic as being functional, which is nice. Now there are a few things I could look at. I mean, we're already now into that stream, so I'm gonna have to decide what is most critical. On the input side, it's pretty straightforward, right? I've got a function here. I'm gonna need to read from the request body some structure, like a JSON structure that has the requests, so effectively different seeds, and then put them together as a through a tar writer instead of using the seed.tar. That stuff we've already got in different parts of the code base, so that's nothing super new. What I would like to try is the in transport compression to see, like right now when we're downloading, we downloaded over the network, as in localhost, the full 4 gig. It's not ideal, so I would want to use the transport compression mechanism for that to only download the 400 megs instead, which would be a lot better. So I know we've done it somewhere in Incus before, and I'd like to do it again. I'm just trying to remember where we did it. Because like we do see it did transfer the old size. Where did we do that in Incus? Let's just Google quickly. Googling HTTP compression. Like I'm pretty sure we've got something with compression directly in our response code. Branch. Stash this mess. Okay. Yeah, we do. There we go. Compress uses compressed gzip. How does that work? So it's in sync response with compress enabled. If compress is enabled, what do we do? Content encoding is gzip. Okay. And what then? Then we just return through a gzip new writer. Okay. Well, that's easy. We can do that. And it's not the content type, it's just content encoding. So let's do that. That should be very straightforward. There might be more to do, like we might need to check a header on the client side to make sure it supports this kind of stuff. But for now, let's not worry too much about that. Let's just do the content encoding gzip. And basically, instead of writing into, basically the file's going to be completely screwed up at this point anyways, but instead of writing into W, we need to write into the compressor. So we'll just do setup compressor comp gzip new writer going onto W. Did it even return an error? Potential error in there? Oops, I was right in the right spot. I just missed it. No, it doesn't. Okay, cool. So it's even simpler. And we just need to defer comp.close. Okay, I need to import compress gzip. Yeah, and then anywhere we're using W, we need to use comp, unless it's for errors, not for errors, but just in all of the copy calls, we need to use comp. Okay. Cool, so we don't seem to use that anywhere else. Build. Yeah, this was debugging, we don't need that anymore. Okay, sure. Okay, and then run the customizer. So if I run customizer and use comp, so it does show content encoding gzip. Received 73, 78, 115 megs. So now we're receiving a bunch of data. And okay, so that's worked out. So the problem obviously is the total size is now all out of whack because it expects the content size is apparently the actual amount of data we're going to send over the wire, which the content length, never mind, which we have no idea what that is now. So we don't really need to do all of that, get the image size stuff here. I'm still keeping the code because we might need to do it in the fallback. But that should be it. So if I just do that, build, there we go, run the code, remove comp, try again. It should once again effectively download 479 or whatever megs of data and lead to a file that's identical, hopefully. That's the goal anyways. And 488 megs, okay. File on disk, that's not good. That's compressed. Okay. So I think the issue is that I did not check for compression effectively. Yeah, okay. So the client needs to communicate that it's ready to do that. I'm completely ignoring the request right now, so that's why the code didn't catch it. If I do compressed, maybe now we're getting the right thing. Because we see request sent off. the request does accept encoding deflate gzip br is standard, and we're responding with gzip. And now we've completed the transfer, and the file is the same size. Okay, so that's good. Comp and out. Hopefully add the same content. Yep, we're good. So that was really just negotiation effectively not being there. I'm actually kind of wondering now what this, yeah, if we can do something about the size, if there's a header to give it the uncompressed size that we're expecting, so that the transfer does the right thing. But otherwise, we can just stream it without giving a size. It just doesn't, it means the web browser won't be able to show a progress bar type thing for the download, which is slightly unfortunate, but not the hugest deal either. So, in any case, we've a bit past the hour, so I'll wrap it up there, but that's working. So that's the most basic implementation of it right now with a fixed seed, fixed everything. But that will let us do an API call that's gonna give us the file. We can compress it during transit, so long as the client supports it. So I'm gonna need to add the actual check for, hey, do we have the accept encoding header set effectively? And if we do, then cool, we'll use that. If we don't, then okay, fine, we'll have to deal with sending the whole thing, which is not ideal. Or more likely what we might do is that we will return the file, but compressed, to effectively tell the client, the file is whatever the ISO name .iso.gz, and then it's up to them to do the decompression, so that we always transfer with the minimum size. But then if the client can do it in the browser directly, then we decompress it in the browser instead of having the user do it. So that's basically the idea. I'm gonna be doing a bit more work on that tool. Gonna see if I also do a quick web frontend for it, or if I've got one of the other guys at Treat Your Fusion who does a bit of web stuff for us to look at doing a basic web form for this. But yeah, that's basically the idea. Is we should be able to have something pretty nice. You can enter the seed information, hit generate, and get your own custom ISO or custom disk image, and just write that, and it would work fine for you. All right. Thanks a lot for watching. Sorry, it was at an unusual time slot. It's not great for Europeans, but that's all I could do today. As mentioned, I think last week and briefly earlier in this live stream, I'm gonna be traveling the next 2 weeks, so a bit of vacation time for me, meaning that I'm gonna be out. Not live streaming next week or the week after. I think I'm actually coming back on Thursday, but that would be a bit crazy to try and get a live stream to fit into that. And I think the week after that is an Incus release, so it might be a little while before the next live stream, but there should be at least a video in a couple of weeks. Anyway, if you've got any questions or anything, feel free to leave them down below. You can go in the community forum, you can check us out on GitHub, ask questions there, and thanks a lot for watching. See you in the next one. Bye.